It's a new way of doing a heat shield. Usually, traditionally, they put a low temperature structure at the bottom, then they put a thermal material on top that will ablate and erode during re-entry. It takes the heat of re-entry. In our case, we put a carbon-carbon structure on top that will take the structural loads and will ablate a little bit, not as much, and then we put a lightweight insulator on the backside. The novel thing about this is looking at this combination of materials for this application, for re-entry of a vehicle into an atmosphere, whether it's Earth or Mars. Insulations are being developed. One of them is by a very small company, but it's a very good, efficient, high-temperature insulation. And then part of it is also an insulation that's being developed by one of my colleagues at NASA Langley. So we are trying to combine those two and come up with a very good insulation system. Some of our team members worked on a Mars sample return and medley, and we are looking at the heating rates that they actually have for those applications and trying to use more realistic heating loads and try to come up with a more realistic design. Our concept will probably be a lot more efficient in terms of volume of the overall insulation package and the structure package, and in terms of mass. Hopefully we will be lighter weight so that we can deliver more cargo to whatever planet we are going to. We are planning to do a lot more analysis and testing of our concept, hopefully in the next year or so, to make sure it's viable. We do a whole bunch of testing at Langley, and we're going to be doing testing at Boeing's facility in St. Louis. And if it's viable, then we can talk to people at NASA headquarters or some of our commercial partners and see whether they're interested in picking it up and working with us and taking it to the next step.